This week, we are reporting here on the lead up to Earth Day, and tonight, the alarming new report on the Colorado River.
Beneath the shimmering waters of the Colorado River, scientists have stumbled onto something so unexpected that it has sent shockwaves across the scientific community. For decades, this river has been known as the lifeline of the American Southwest, feeding cities, powering dams, and carving canyons older than civilization itself. But now, researchers say the ground beneath it is stirring, and what they've found could rewrite everything we thought we knew about this landscape. It started like any other survey. Geologists were mapping sedimentary layers beneath the Grand Canyon, just another data collection mission. But when seismic imaging came back, the patterns looked wrong, disturbingly wrong. Instead of stable rock, the scans revealed heat signatures, shifting densities, and deformation patterns deep below. At nearly 25 kilometers beneath the surface, they detected a vast chamber of molten rock, a magma body hiding where no one expected it at first. The team thought it had to be an error. The Colorado Plateau isn't exactly famous for volcanoes, but as the days passed, more instruments confirmed the same thing. There was heat, there was pressure, and there was movement. The magma wasn't sitting still, it was pushing, expanding, alive. And this wasn't just another geological curiosity. It was a discovery beneath the very river that sustains 40 million people across 7 states. A lifeline of water, agriculture, and electricity now had a molten threat building quietly below. Months before the discovery, satellites had picked up something odd. Ground in the Glen Canyon region had been rising only by millimeters at first, but consistently, year after year. Small changes most people would never notice, but in geology, millimeters mean everything. When the data was cross-referenced, the picture sharpened. Thermal satellites showed subtle hotspots near the same area. Then came the earthquakes. Not big, city-shaking ones, but clusters of tiny tremors, shallow and precise. They weren't tectonic quakes caused by plates grinding. They were the kind geologists recognize instantly, the type caused by magma forcing its way through rock. Finally, gravimetric surveys delivered the last piece. Instruments detected a steady decrease in density beneath the riverbed, a signal that heavier rock was being replaced by lighter molten material. Together, these signs told a chilling story. Magma was on the move. At first, the idea of volcanic activity beneath the Colorado River seemed ridiculous. This isn't Hawaii or Iceland. The Southwest is carved by erosion and uplift, not lava. But when geologists pulled out the region's tectonic history, they realized they might have underestimated it all along. The crust here is thinner than once believed. Beneath it lies a mantle zone, rich in gases and fluids, ingredients that lower the melting point of rock, making magma easier to form. And while no one alive today has ever seen a volcano here, the rocks tell a different story. Ancient lava fields scattered across the Colorado Plateau prove that magma has erupted in this region before, not in human memory, but within Earth's recent past. That raised a possibility no one had dared consider. What if this wasn't a dying system, but a new one waking up? Once the alarm was raised, monitoring intensified. Seismic sensors, gravimeters, and gas analyzers were deployed across the river basin. Then came the cutting-edge tools. Muon tomography, a scanning technique that uses cosmic particles, revealed the magma chamber wasn't just inflating upward. It was spreading sideways, feeding into weaknesses in the crust. Gas spectrometers confirmed rising levels of carbon dioxide and sulfur compounds leaking through fissures. These gases weren't high enough to pose danger yet, but in geology, their presence is a warning. They mean pressure is building. The proximity of all this to critical infrastructure made it even more alarming. Glen Canyon Dam and Hoover Dam, the powerhouses of the Southwest, now sat within potential influence zones. If the chamber expanded too far, the stability of these megastructures could come into question. On its own, magma moving underground might not be an immediate threat, but beneath the Colorado River, the danger multiplies. Because here, molten rock doesn't just sit beneath dry earth, it sits beneath one of the largest freshwater reservoirs in the nation. And when magma and water meet, the result can be catastrophic. It's called a phreatomagmatic eruption. Imagine boiling a sealed pot of water until the pressure blasts the lid off. Now replace the pot with the Earth's crust and the lid with solid rock. Even without a towering volcano, the result can be devastating, violent underground steam explosions powerful enough to rip open the surface. For scientists, this possibility is rare but real. And with billions of gallons of water flowing above it, it's a scenario they cannot ignore. As teams dug deeper, the mystery only grew. Fresh analysis suggested this wasn't an isolated pocket of magma, but part of something larger. Isotopes in gases escaping from nearby springs pointed to deep mantle origins, the kind linked to mantle plumes or hotspots. That meant the Colorado River discovery might not be a one-off. It could be the beginning of a regional magmatic awakening stretching across Utah and Arizona. Some scientists even proposed that long-term climate change, shrinking snowpacks and lighter surface weight on the crust may have altered the balance, letting magma rise more easily. The question was no longer just what's happening under the river, but is the entire Southwest reawakening? What happens underground never stays underground for long. Subtle shifts began appearing on the surface. Springs that once ran cold now bubbled warmer, carrying strange minerals like lithium and arsenic. Native vegetation, reliant on shallow aquifers, showed signs of nutrient stress. Ecosystems were being nudged by forces they couldn't see. Aquatic species reacted to rising water temperatures. Groundwater chemistry shifted in ways that hinted at deep fluids seeping upward. For engineers, this was even more concerning. Bridges, pipelines, and dams were reassessed with new seismic models that included magmatic pressure. Insurance companies reviewed risk zones. Even policymakers began revisiting emergency plans. What had started as a small geological curiosity was now reshaping conversations in water management, civil engineering, and even national security. As scientists struggled to decode the signals, they found themselves turning to an unexpected source: the people who had lived along the river for centuries. Native American tribes, like the Hopi Navajo and Hualapai, had long told stories of the earth breathing, of fire beneath stone, of springs that once boiled without warning. For years, these stories were seen as metaphor. But now, geologists began to wonder, were they memories of ancient geothermal events? Elders spoke of warm ground patches and drying springs generations ago. These oral traditions, passed down for centuries, might hold echoes of the same magmatic forces now stirring again. Modern science and ancient knowledge were converging, telling one story through two different languages. The earth beneath the Colorado River is alive. With the mystery deepening, new initiatives were launched. Subsurface observatories linked by AI now scan every tremor and gas leak in real time. Machine learning combs through millions of data points, searching for patterns no human could spot. Controlled seismic tests are being run to map the exact edges of the magma body, and advanced simulations now play out hundreds of possible futures. In some, the magma stabilizes quietly. In others, it intrudes further, creating a long-term volcanic field. And in the most dramatic scenarios, magma surges upward into groundwater, triggering explosive bursts that could transform the landscape overnight. No one knows which path reality will follow, but every day, the models grow sharper. For now, the Colorado River still flows. Families still drink from it, farmers still draw from it, and cities still light up from its dams. On the surface, nothing has changed, but deep below, molten rock presses upward, reminding us that the ground we stand on is never as stable as it seems. The discovery beneath the Colorado River isn't just a geological event. It's a wake-up call, proof that even the most familiar landscapes can harbor secrets powerful enough to rewrite history. And as the data keeps pouring in, one truth is certain: the story of the American Southwest is not finished. It is still being written in heat, stone, and silence, waiting for the moment when the Earth decides to reveal what it's been hiding all along. This week, we are reporting here on the lead up to Earth Day, and tonight, the alarming new report on the Colorado River. beneath the meandering course of the Colorado River, where sandstone cliffs and ancient rock strata tell the silent story of eons past, geologists have uncovered a phenomenon so unexpected, so urgent in its implications, that it has triggered a rare red alert. An urgent scientific call to immediate attention. The discovery was made during a routine subsurface mapping project initially aimed at tracking sedimentary evolution in the Grand Canyon corridor. However, what began as a standard geological survey quickly transformed into a high-priority investigation when seismic imaging revealed something staggering beneath the riverbed. Before we start, smash the like and subscribe buttons for more updates. Deep below the surface, in a zone once thought to be geologically stable, researchers identified signs of a previously undetected magma body, an enormous chamber of molten rock that appears to be expanding. Nestled at a depth of approximately 25 kilometers, the structure emits heat signatures and deformation patterns indicative of active magmatic intrusion. Even more concerning are the pressure anomalies detected by borehole sensors, readings that suggest significant shifts in subterranean stress, pointing to a potential escalation in geothermal activity. This is not merely a curiosity for academic discussion. The implications of an actively inflating magma chamber under such a critical watershed stretch far beyond geological interest. The Colorado River is not only a natural marvel, but a lifeline. It supplies water to nearly 40 million people across 7 US states and supports massive agricultural networks and hydroelectric infrastructure. Any shift beneath its bed could pose dire consequences not just for geology, but for the economic, environmental, and societal structures intricately dependent on the river's consistent flow. Evidence began to accumulate several months ago when satellite-based interferometric synthetic aperture radar in SAR detected minute uplift in a specific section of terrain near the river's midsection around the Glen Canyon region. At first, the displacement appeared minor, a few millimeters of vertical lift per year. Nothing extraordinary on its own. But as geologists cross-referenced this data with thermal anomalies recorded by orbiting instruments and ground-based seismic readings, a pattern emerged that could not be ignored. A swarm of low-magnitude earthquakes followed, subtle yet highly localized. These were not tectonic quakes, but the kind associated with fluid migration and rock fracturing, hallmarks of magmatic movement. The seismic signatures were shallow, originating from around the depth of the suspected magma body, and they were accompanied by fluctuations in local gravity measurements. Gravimeters deployed across the region detected a slow but steady decrease in subsurface density, consistent with the accumulation of lighter molten material replacing denser rock. These signs, uplift thermal output, microseismicity, and gravitational shifts, collectively pointed to one chilling conclusion. Magma is on the move, and it's doing so in a place where it was not expected, where no volcanic system had been known before. This is what prompted the red alert. The geological equivalent of sounding an alarm, the U.S. Geological Survey (USGS), in coordination with several university-led geoscience teams, moved quickly to classify the zone as a site of elevated magmatic concern. That designation is not handed out lightly. It signals the presence of subterranean activity with the potential to evolve rapidly, with limited precedent to predict its behavior. The idea of volcanic activity beneath the Colorado River may seem implausible at first glance. The area is not known for recent volcanism. Most of the landscape was shaped by ancient forces, uplift, erosion, and sedimentation, not lava flows or pyrrollastic surges. But deeper study has revealed that the region's tectonic history is far more complex than previously believed. The crust here is thinner than in surrounding areas, and it rests above a mantle zone rich in volatiles, gases, and fluids that lower the melting point of rock and allow magma to form under conditions previously thought improbable. Moreover, historical data now being re-evaluated with fresh urgency shows signs of past volcanic episodes in the broader Colorado Plateau, albeit from millions of years ago. Ancient lava fields and basaltic dyes suggest that magma has surged through this region before. even if not in the lifetimes of any human civilization. The possibility now being examined is whether a new magmatic system is reactivating, not from the vestiges of an extinct volcano, but from a nent one still forming in the deep shadows of the Earth. This discovery has opened an entirely new chapter in the geological understanding of the American Southwest. Teams are working around the clock to refine the subsurface imaging, deploying muon tomography systems, technology that uses cosmic particles to create high-resolution scans of underground structures. Preliminary models show the chamber expanding laterally, not just vertically, suggesting it is feeding off a broader mantle anomaly. Some fear this could be the beginning of a larger magmatic system developing along an uncharted line of weakness in the continental crust. Compounding the concern is the proximity of major infrastructure. The Glen Canyon and Hoover dams, downstream hydroelectric giants, lie within potential influence zones if the chamber continues to grow. While there is currently no indication of imminent eruption, the deformation patterns and rising gas emissions, especially increases in carbon dioxide and sulfur compounds from deep fissures, signal that the crust is under stress. These are not yet the emissions of an erupting system, but they are red flags indicating active degassing, a precursor in many known cases to more aggressive magmatic behavior. Ground teams have installed dozens of new monitoring stations from tilt meters that measure minuscule changes in ground angle to spectrometers, analyzing the composition of gases venting through the soil. Every data point feeds into real-time simulation models attempting to predict whether this magma body will stabilize or whether it will continue to ascend toward shallower levels, where it could interact explosively with groundwater. That interaction between magma and water is a particular point of dread for geologists. When magma encounters water-bearing layers near the surface, it can trigger phreatomagmatic eruptions, sudden violent bursts caused by the rapid conversion of water to steam. These types of eruptions don't require a surface volcano to be dangerous. Even a modest intrusion that flashes underground aquifers to steam can tear open the crust with incredible force. What makes the situation beneath the Colorado River especially precarious is the enormous volume of water directly above the potential activity zone. If upward magma movement continues unchecked, the risk of such an interaction, however remote it might seem at present, cannot be dismissed. Another concern lies in induced seismicity. As magma moves, it forces rock apart, generates fractures, and reactivates old fault lines. While the initial swarm of microearcs was low in magnitude, there is potential for larger seismic events if the pressure buildup continues. These would not be conventional tectonic earthquakes, but rather volcano-tectonic quakes, earthquakes caused by the fracturing of rock due to magmatic pressure. In a region with aging infrastructure and dense population centers relying on the river, even moderate quakes could lead to disruption. Geologists are proceeding with caution, balancing scientific rigor with the weight of potential consequences. At this point, the magma body is considered intruding but not yet eruptive. It is, however, highly dynamic. The red alert serves as a formal acknowledgement that a significant geological process is unfolding, one whose future trajectory is uncertain. This uncertainty is a driving force behind the urgency. Geology rarely offers fast answers. Rock moves on timescales far slower than human perception, but this case is different. The convergence of multiple high-resolution monitoring technologies, combined with the scale and importance of the affected region, means every change is being tracked with unprecedented speed and precision. Scientists are not merely watching for signs of eruption, they're also trying to understand why this is happening now. Some suggest that shifts in the lithospheric stress field, perhaps related to broader tectonic reorganization in the western United States, may have reawakened ancient mantle processes. Others point to long-term climate changes, where reduced surface loading from diminishing snowpacks and water reservoirs could subtly alter the pressure dynamics in the crust, allowing deeper fluids to rise. These ideas remain hypotheses, but they reflect the scale of the mystery. The discovery beneath the Colorado River is not just a singular geological event, It's a keyhole into processes that shape continents, reconfigure hydrologic systems, and remind humanity of the dynamic forces lurking beneath even the most familiar landscapes. As data continues to stream in from satellites, drones, and ground teams, each new measurement adds dimension to a subterranean narrative still being written. What began as a quiet anomaly, a subtle bulge in the terrain, has turned into a full-scale scientific mobilization, an effort not only to decode the message written in heat and stone, but also to anticipate what that message might become. While the magma remains